So here are just a few more examples of breaking down radicals to simplify them. Remember, the less stuff you have under the radical, the more simplified it is. So here's another example. On this one, I can't square root any of this, and I can't square root any of this. So I'm probably going to want to combine it first. You could break the 12 down, but I'm going to go ahead and use the product rule and combine this all into one radical, 6x times 12x. 6x times 12x, well, 6 times 12 is 72, and x times x is x squared. And now let's see what we can do with this. I've combined them, which is good, but I want to help some of this stuff get out from the radical, ultimately. 72 does not square root evenly, but maybe I could break it into something that does square root evenly. It divides by 9, but the biggest thing we could divide it by would be 36 and 2. If you go for the biggest thing, it'll be less work. So 72 splits into 36 and 2. I could have picked other options, but the reason I picked this one is because it square roots evenly. Square root of 36 is 6. All right, that was all just the 72. Now I also need to square root the x squared. So basically I'm splitting it into the square root of 72 and the square root of x squared, which is again the product rule. The square root of x squared is just x. Be careful, once you've used the radical, you don't need to write it. So I should not have a radical over that x. It is broken free of the radical. Typically we write the stuff that's not got a radical in front, and we put the radical on the end. So I'm just going to rearrange this as 6x root of 2. Either of those are fine, but sometimes it's confusing to see, like, does that go all the way over the x or not? I'm not sure. So that's why we put the x up front usually. So that's the final answer on that one. Let's try another kind of bigger problem. Okay. Again, we could break down some of this, but I like to multiply it all together and then worry about it as one problem. So I'm going to go ahead and multiply all this together. 18 times 6 is 108, I believe. And then you've got x to the 5th and x to the 4th. Total, that makes 9, x to the 9th. Okay. This is all still under the radical. I haven't used that radical yet. And now, like we did before, this is all combined, which is good, but if I can help any escape the radical, it's more simplified. So kind of break it down in pieces. Break down the 108 and break down the x to the 9th. 108, again, try just with your calculator, see if you can divide 108 by any perfect squares. Like, does 108 divide by 4 or by 9? I think the biggest thing ends up being 36 and 3. Yeah. 108 does split into 36 and 3. Again, if you don't start with that, it's okay. Like, let's say we split 108 and 9. Oops, sorry. That would be 12 and 9. Say you split 108 into 12 and 9. This is good because we can square root the 9, which is just a 3. But the square root of 12 keeps going. So we'll need to break 12 into 4 and 3. We could have broken 12 into like 2 and 6, but that's not helpful because I can't square root 2 and I can't square root 6. So pick something that you can square root, like 4. The square root of 4 is 2. And now I gotta combine everything. Again, we're not adding, we're multiplying here. This is 2 times 3, which is 6 root of 3. That whole process would have been a little easier if I'd picked 36 and 3 up here, but that's okay. I wanted to show you that it's all right if you do it the long way. Now let's break down x to the 9th. 9, there's nothing that multiplies by itself to give me x to the 9th. So I'm going to have to break it into something that I can square root, like x to the 8th. Anything even will work. X to the 8th times another x would give me x to the 9th. And the square root of x to the 8th would be x to the 4th, because x to the 4th times another x to the 4th gives me x to the 8th. Or 8 divided by 2 gives you 4. This square root of x will stay as it is. And now I'm going to combine these two right here. So anything on the outside we put in front, like 6 times x to the 4th. And anything under the radical, like square root of 3 and square root of x, square root of 3 and square root of x, we can actually go ahead and just combine those. So this would be 6x to the 4th times the square root of 3x. Just combine those in the same radical. All right, I know these can get kind of long. Let's look at just a couple more. All right, this is a pretty big number. So again, I just take that number and start dividing it by 4, by 9, by 16, all those perfect squares. I noticed that this is like a multiple of 50. So it's probably a multiple of 25 too. And 25 is a perfect square. 450 does split into 25 and what is it, 9? Oh, 18. 25 and 18 will work. The square root of 25 is 5. If you'll notice, 18 actually keeps breaking down, so we'll need to keep going here. 18 splits into 9 and 2, and the square root of 9 is 3. So again, don't add, you multiply. 5 times 3, which is 15, root of 2. As far as the variables go, just take it one step at a time. We'll do the square root of x to the 4th, and we'll do the square root of y to the 5th. And then ultimately just multiply it all together, because it was originally being multiplied. Okay, the square root of x to the 4th is x squared. The square root of y to the 5th, can't really do that, so we're going to have to split it into a couple y squareds, or you could do y to the 4th times an extra y. The square root of y to the 4th is y squared, but we still have an extra square root of y hanging around. So it's kind of hard to keep track of everything sometimes, but by the time we were done, we had this, and we have this. Everything on the outside I'm going to multiply together. So 15 times x squared times y squared. And everything under the radical that hasn't escaped yet gets multiplied together. So 2 and y. That is my final answer. Let's do one more that involves a cube root. You won't see a whole lot of these in Algebra 1, but just in case you ever see a cube root, 48 x to the 7th y cubed. Let's try this. If it ever cube roots evenly, great. Remember, numbers that cube root evenly would be often 8 or 27. Those cube root evenly. 48 does not cube root evenly. Nothing times itself 3 times gives you 48. But, like we've done in the past, I could split it up into something that does square root, or cube root evenly, like 8. Split it into 8 and 6, and cube root the 8. The cube root of 8 is 2. Just plain 2. It's escaped the radical at this point. Cube root of 6 is not 2. 2 times 2 times 2 gives you 8, not 6. So the cube root of 6 is just going to have to stay as it is. And now let's break down these variables here. The cube root of x to the 7 and the cube root of y cubed. Let's start with this one. This one's easier. Cube root and cubed just cancel each other out. You just get y. Basically, it's like what times itself 3 times gives you y cubed? Well, that's y. Y times y times y gives you y cubed. Things that will cube root evenly have to be divisible by 3. 7 is not divisible by 3. So there's a couple ways you could handle this. We could break x to the 7th into like x cubed times x cubed times an x, because that would be 3, 6, 7 of them. And then I could cube root that, and I could cube root this, and I couldn't cube root that, but that's okay. The cube root of x cubed is x. This cube root of x cubed is x. And then I've got 1 cube root of x left over. That would give me x squared times the cube root of x. Another way you could do that is, instead of breaking it into cubes, we could have just made this x to the 6th times another x, because x to the 6th will cube root evenly. Like what times itself 3 times gives you x to the 6th? That would be x squared. Because x squared times x squared times x squared 3 times gives you x to the 6th. And then again, I've got a little cube root of x left over. Either way, I get the same thing. As always, we've got kind of a mess here at the end. This is left, this is left, this is left. On the outside, I have 2x squared y. And under the radical, which is a cube root, I have 6 and x. Again, you're not adding any of this. It was all multiplication to begin with. It should be all multiplication by the time you're done. Just to wrap this up, here are all the tools we've talked about so far. We talked about the product and quotient rules, and now we've talked about using perfect squares or cubes to break it down to help part of the radical escape from underneath. So those are the tools we've talked about so far. There will be more, but that's kind of a summary so far.